Welcome. Thank you for having me. What you're looking at behind me is the cockpit of a DC-3 airplane. So that plane was built in 1935. And the thing you should notice about the cockpit is that every dial that you see there, every control, every display indicator, every gauge, and every switch is actually connected to the airplane itself in some way. So if you pull back on the control stick of a DC-3, you're actually pulling wires which are connected to the control surfaces of the plane, and then the plane is moving through some form of direct manipulation. It's very different than a modern airliner. On an Airbus 380, for example, you have a bunch of iPads, you have a bunch of glass screens, which are essentially output devices from a computer. You have a bunch of buttons and switches, which are input devices to a computer, and everything you do with that airplane is controlled by software, and everything that the pilot does is mediated through software. Instead of a control stick, you have a keyboard, which is convenient for updating your Facebook posts or whatever it is that you're trying to do while you're flying the plane. And that is a metaphor for everything in modern life. A lot of things that we used to do directly, by manipulating things directly, we now do through software. Instead of using an alarm clock, you run a little program which wakes you up. Instead of sending a message by writing a note and giving it to somebody, you use software to send a message to somebody. Instead of hailing a taxi, you could use Uber. Soon in Helsinki, one day, we will be able to use Uber. Think about the mediation of software. This is a warehouse at Amazon.com, what they call a product distribution center or something like that. And there's a bunch of workers wandering around there filling up boxes with things. But the workers really have no idea what they're doing. What the workers are actually doing is following instructions on a computer which is strapped to their wrist, which is literally telling them exactly where to walk, what to do, what to pick off the shelf. They don't have to know what it is. They just have to scan it with a little barcode and throw it in the box. And so the entire process is mediated through software, through computer software. And in fact, when you think about it, those workers in an Amazon warehouse are really just a kind of output device for the software developer who's trying to write code that is going to cause a box to be packaged and shipped and sent somewhere. And in fact, if the software developers wanted to, they could cause all the workers in the Amazon warehouse to go gather out on the lawn in front of the warehouse and spell out the programmers' names in gigantic letters, and then you could take a picture with a drone or something. You could do that. It would be a lot of fun if you're an Amazon programmer, although you would probably get fired. Now, one day, all this software that is running the Amazon warehouses was created by human beings, and one day the human beings writing the software noticed that the very short workers couldn't reach the top shelf. And they were having trouble picking things off of the top shelf, and they had to stop and go get a ladder or climb up on the shelf, and the shelf would fall over, and all kinds of things would go wrong. And so they actually went to the Human Resources Department and got a database of the height of all the workers, and they changed their code so that short workers do not have to pick things off of the top shelf, so that when something is needed from a top shelf, a tall worker will be sent to get that. And that is either really kind of evil or pretty cool when you think about it, but it's one of the advantages of having software in the middle of everything rather than letting humans get involved, because the software can do all kinds of things. The software can have opinions, it can mediate. That software is created by human beings who are sitting there writing the software. And so what I'm concerned about is who those human beings are, the software developers, the programmers who are creating all that code that will run in the future and will define what the future will be like. Let me tell you a little story, a hypothetical story, for example. Tell me if this ever happened to you. You call up your best friend. You say, I've been invited to the holiday party. Would you like to go with me? And your best friend has some excuse. I'm sorry, I can't go. I'm sick, I'm busy, I'm tired, I'm really slammed. I'm not even in town. Okay. Then, 2 days later, you log on to Facebook, and you discover that your best friend actually went to the party with, I don't know, your ex-wife or something. Did that ever happen to you? This is a scenario that actually increasingly happens that Facebook, for some reason, Facebook has decided to show you a picture of something that happened in the world that it thought you might be interested in, because it's got your friend and it's got somebody who's still your friend on Facebook, which happens to be your ex-wife. And nevertheless, this is a very frustrating experience, and now you're going to be sad for 6 months. That is the problem with the mediation, I think, of software, because Facebook, unlike the Amazon software, the Uber software, or the software that runs alarm clocks, is actually mediating not between you and objects in the world, it's mediating internally in between human beings, in the lives of human beings, in a way that becomes very important. A bunch of researchers, academic researchers, got together with some people at Facebook, and they did a study. And in the study, they had, I think, 689,000 people, or some number like that, 689,000 people in the experiment, and they manipulated the Facebook feeds of these people, and they showed some of them happy stories and some of them sad stories, and there was probably a control group. And what they discovered, this is brilliant, academic researchers are absolutely amazing. What they discovered is that when you show people happy stories, they become happy, and when you show people sad stories, they become sad. And I guess we never could have expected that this would happen, but it did. They had to call it emotional contagion, which is a fancy, highfalutin academic word for what was going on. It was not a very insightful study. It was something you could have expected, that showing people happy stories will make them happy, sad stories will make them sad. What I think they didn't expect is that there was a big uproar, and there was a lot of complaint that the very fact that Facebook conducted this study was unethical in attempting to manipulate people's emotions without their permission. This was an ethical breach. And what I want to know is, what do you think Facebook does anyway? What do you think they're doing all day long in the first place? They are not showing you every single thing that can be shown to you, every single thing that's happening to any one of your friends. There's an algorithm written by developers using machine learning, which is actually just a bunch of matrix multiplication, that is attempting to choose some things to show you almost entirely at random, and based on some algorithm, based on some considerations. What are those considerations? What is Facebook trying to optimize for? What do they want to create? What are their goals in choosing which stories to show you, which they do all day long? Their only goal, really, is not even to serve science, to find out that there's emotional contagion. Their normal goal is to get you to keep using Facebook. That's what they're really optimizing for. They're looking for things that they can show you that will cause you to engage, and by engage they mean to be interested, to say like, to share with a friend. That's a sign that you're engaged by that particular thing. And now you have this algorithm whose entire goal in deciding what news the world will see is what is engaging. What will people click on? What will they be interested in? When we started building social networks, I say we, but it wasn't me, but when the tech industry started building Twitter and Facebook and the likes of them, there was a lot of news about how wonderful this was going to be for democracy, and how these were the tools of revolutionaries in dictatorships throughout the world could use Twitter to communicate amongst one another, and so on and so forth. And it was all seen as very utopian, and Twitter and Facebook were going to be great for the world. It reminds me, those of you that are over the age of 90 in this room will probably remember that at some point even television was presented as if it was going to be this wonderful thing for the world, and all kinds of peasants in Egypt will watch television and they will learn how to bake bread or open banks, and the world will become a much better place through the educational abilities of television. And what really happened is that we got Lucille Ball and Louis C.K. and a bunch of stupid stuff. Okay, what I think a similar thing happened with the social media, which is that we started out kind of hoping that all this communication would be for the better. And what we got instead were bubbles. Bubbles where the people on the left only heard the news of the left, the people on the right only heard the news on the right. Everybody in America was surprised that the right won the presidential election. They were only surprised because they were only listening to people like themselves because of the algorithms in Twitter and Facebook. The New York Times actually dissected what was going on, what goes on here, and how that false news spreads. And it's actually fairly important. This fellow on Twitter was wandering around in his hometown of Austin, and he saw a bunch of buses. And he also saw demonstrations, or he had heard that there were protests against Donald Trump in Austin. And so he wrote this false tweet, and he said, anti-Trump protesters are not organic, here's the buses that they came in. And the tweet essentially purported to show buses that had been used to bring in demonstrators from, I don't know, Mexico, presumably. The buses were actually there for a tech conference, which happens in Austin all the time. But the story took on a life of its own, because this was the kind of story that the people in that particular echo chamber could get excited about. They could rant and rave about this particular thing, and it spread through Reddit on the Donald subreddit. And it got all the way to the point at which the president-elect of the United States of America was telling this story that was false, that was made up, that was based on nothing, that was based on one person with a Twitter account that just thought something was interesting. And the story was spread not because it was true or important. The story was spread because it made people angry. And it made people a combination of righteousness and indignation, which is the perfect formula for spreading things on Twitter and Facebook. There's a quote, a lie gets halfway around the world before the truth has a chance to get its pants on, and I think this lie is now sort of permanently enmeshed in people's minds, the idea that that there were professional protesters protesting against Trump. In the old days, in the days before social media where any idiot with a camera could spread a false story, you had printing presses, and the printing presses cost a lot of money, and so you had a sort of sense of responsibility to the world to only somehow cover news that it is in some way, some form of journalistic ethics were considered. But I think now many of the people working in the tech industry are wondering if we have inadvertently, instead of building this utopian mechanism, because of just the way that the social networks work and the way that that software works, maybe what we've built is the Ministry of Truth instead. Everything I'm talking about here is enabled and created through the mediation of software, because software exists to mediate between human beings. What is software? I want to analyze it for 10 seconds. Software is a bunch of lines of code. What's a line of code? There's a line of code. A line of code encapsulates, there's two things to know about it. One is that it will run in the future. Therefore, it is a thing, and probably run a lot of times in the future, and therefore, it's the future in some ways. This is the future. It's just a tiny bit of the future, but when you add it all up, it's a lot of the future. The second thing about this line of code is that it represents a lot of decisions, a bunch of individual decisions that were made by a software developer. Every single word, every single line, every parameter, every function call is a tiny decision that was made by a programmer, and that decision will have its impact on the future. And that's why at Stack Overflow, we say that developers are writing the script of the future, because that's what you're doing if you're a software developer. You're sitting there writing a script that will execute in the future, quite literally. Now, here's the other thing to know about software, which is that it's gotten really, really complicated in approximately 30 years. Since I started programming 30 years ago, it was much, much simpler. When I started programming, this is VisiCalc. This is the most popular software program of all time, was this thing running on an Apple II computer. The Apple II computer, the CPU chip of an Apple II computer, which this thing I'm holding in my hand, I don't even know what it is. It probably has more brains than an Apple II. The Apple II could do addition, subtraction, maybe multiplication. Division was like way too complicated. That is too much to ask. You literally could not do division on an Apple II without writing some code, custom code, to do the division. When I learned how to program for Unix when I got to college, this is 1987, you could take these two books, and they were less than 200 pages, and you knew everything that there was to know about programming for Unix. It was really simple. One of the big things that's changed is we now live in this world of software soup, of Uber and Stripe and payment processing systems and Google Maps and all that kind of stuff. And so when we create software today, you can use any of that soup in your code very, very easily. If you want to display a map, you can use Google Maps to display a map in a millionth of a second. If you want to summon a car that will come and pick you up, not in Helsinki, you can use Uber, and you can use their API, and it will cause a car to arrive with about 1.5 lines of code. If you want to cause a payment to take place, you can use the Stripe API. And you could combine these things, and you can create enormously complicated code that does all of this stuff with about 10 lines of code. And it's pretty amazing, actually, when you think about what it's doing. Google Maps, I mean, there are satellites in space that have high-resolution photographs of the entire planet, and you're able to use that in your own code with the one line of code. You're able to cause a vehicle to arrive. A human being will drive a vehicle. Don't get me started about how many lines of code are in that vehicle. A human being will drive a vehicle and come pick you up with another couple of lines of code from Uber. The payment processing system of the world's credit cards that spans, I don't know, 200 countries and 9 zillion, that's the actual number, 9 zillion lines of code that go into the entire global payment processing system, and you can summon it with Stripe with just a few lines of code, about the same number of lines of code as it would take to divide numbers on an Apple II computer. So that's how complicated it's gotten. But what does that mean? What that means is that sometimes things go wrong, and when they go wrong, it's very, very hard to debug them. So let's say that you put up a Google map in your app, and it only takes this one thing, which I would call a line of code because I only see a couple of semicolons, it's 2 lines of code. You display a map in your code, and you discover, lo and behold, that when the user plays with a scroll wheel on their mouse, that the entire map zooms in and zooms out, and you don't want that to happen, and you're trying to disable the scroll wheel. And you don't know how to do that because you don't understand anything about Google Maps. You just have this very simple piece of code you copied from the internet and pasted into your code, and it works fine, and you see a thing called scale control, and you think, oh, I don't want to scale, so I will set that to false, and you try that, and it doesn't work. So what do? Again, you have no idea how Google Maps works. You could go buy the book. It's 465 pages. You could wait for Amazon to deliver the book. You could read the whole book from beginning to end. You might have a little bit of a theory as to how Google Maps kind of works, and you might find in that book somewhere the answer that you want. Or you could go online, and you could type into Google Maps, scroll, map, disable, scroll wheel. And you would probably land on this question, which has already been asked, and if it hadn't already been asked, you could ask it yourself, and there would be an answer down there, which somebody had provided about how to solve this particular problem that you're facing on Stack Overflow, for example, which is a website that Jeff Atwood and I launched in 2008. A couple of things to notice about Stack Overflow. Stack Overflow is got, at this point, 13 million questions on it. That's just on the programming site. There are 150 other sites on other topics. There are already 20 million answers that have been provided by programmers around the world. We get 113 million human beings, monthly uniques, that visit our network, and something like 781 million monthly page views. So it's an absolutely gigantic network. One of the things that Stack Overflow does that's a little bit different than all the sites that came before it is that we have voting. So when you see an answer, you can vote it up or vote it down based on whether or not you like that answer. And that feature alone makes Stack Overflow a much more powerful resource for developers who are trying to solve their particular problems. That voting leads to reputation. And if you write an answer that gets an upvote, your reputation will go up, and you can see this on your profile on Stack Overflow. Whoever wrote that answer will have a higher reputation. We also keep track of how many people you're helping, really, by writing these questions. And that feeds into the next question I always get is, how is Stack Overflow a business? How do you make money? And the answer is that we look for the programmers that are doing a great job on here, and we get them great jobs. So your profile on Stack Overflow, rather than just showing the work that you do on Stack Overflow, now allows you to create a developer story. The developer story talks all about what you've done, where you've been, what you've built, what you know and what you don't know. And the developer story, if you choose, if you select a box, can be shown to certain employers that might want to hire you through our product called Stack Overflow Talent. Now, let me bring this together because it sort of sounds like a weird kind of combination, but the world has gotten to be such that everything that we do in the world is mediated through software. And it's simple things like an alarm clock or hailing a taxi that's done through software, and that's not a big deal. But when presidential elections are happening through software, that is a big deal. And those decisions that those developers are making through the software are incredibly important, and it's incredibly important that we consider who those developers are that are writing that software, and that we think of them as sort of the philosopher poets of this day and age. And that is why we at Stack Overflow are so obsessed with developers, and why at Stack Overflow our mission is to help developers learn, share their knowledge, and level up. Thank you very much.